Today's lesson is 12.2 on surface area of prisms and cylinders. Starting out with a little vocabulary, the first term of the day is lateral faces. These are faces that are not the bases, which are the parallel faces, as a reminder. So I'd like you to go ahead and draw this triangular prism over here to the right. And the bases would be the two that I'm about to highlight in green. So that triangle and then the other triangle back here, those are the two congruent ones that are also parallel. So those would be the bases. And then the lateral faces would be everything else. So there would be one rectangle back here. There'd be the one on the bottom. And then there would also be the one on this side over here as well. So that one would have 3 lateral faces, 2 bases. So a total of 5 faces. The altitude has a meaning that is pretty similar to the definition that we've used for other shapes. It's perpendicular, which was true whether it was a trapezoid, a triangle, a parallelogram, etc. And it joins the 2 bases, and that will function as our height. I'd like you to go ahead and draw this rectangular prism. And then in each one we can kind of label this one, since that's going to be a right angle, that would be our height. And then the bottom, this would be one base. And then the top could be the other base, or you could make it the sides as well. For our triangular one, the height or the altitude is not going to go from top to bottom because the bases go side to side like that. This measurement would be the height. So that would be this part here, which would be the same as this part, which would be the same as that part. So any 3 of those would be considered the height because they join the 2 bases. And then the first thing we're going to learn to calculate today is the lateral area. And this is the sum of the area of the lateral faces. So you're only adding up the faces that are not bases. And the formula for each one, L equals PH, is what we use when it's a prism. P, as it's been before, stands for perimeter, H for height, and then L equals 2 pi RH is what we use if it's a cylinder. And again, like it's been, pi, we'll use the pi button, R will be our radius, and then H will be the height. Go ahead and draw this cylinder. Mark a couple things with me. The radius of the cylinder is the radius of either of the bases, and then the height, the H, is what connects those two, so that would be our height. There. Surface area is an extension of lateral area, and it's the sum of the lateral area, so we just looked at, and the area of the bases. So it is the total area of every face on the shape. If we are working with a prism, here's our formula. Surface area prism is capital P times H plus 2 capital B. And labeling a little bit, the P is again our perimeter. The H will again be the height. And then a new one that we haven't used yet this year, if it's a capital B, it's not just base. It is the area of base. So whatever shape the base happens to be, we'll have to find the area of that, whether it's a triangle, a trapezoid, an octagon, whatever. And if it's a cylinder, here's our formula. Surface area of a cylinder is 2 pi RH plus 2 pi R squared. And I think what you'll find, cylinders, there's just not as much going on because the radius is the radius. That's not really going to change. Sometimes you might have the diameter, so you'll split it in half, and then the height will still be the height. Prisms can vary a lot because the base could be any polygon at all, so there's going to be some variance as to how we find the perimeter and how we find the area of the base. So what we're going to do for the rest of this is just practice finding these 2 things. So most of them will ask for both the lateral area and the surface area. We're going to make sure we do that on the ones that ask for. So example 1, we start now to find the lateral and surface area. So we want to have two answers, one for the lateral, one for the surface area. So go ahead and draw this thing, and as you're drawing it, you're always going to want to think to yourself, what shape is it? So in this case, we definitely have a prism. And our formulae were that the lateral area was the perimeter times the height, and the surface area is that same perimeter times height, but plus 2 times the areas of the base. So our first decision would be, what's our base, what's our height? We need to make that decision before we can do anything. And with a rectangular prism, there's no wrong answer to that. Any two parallel faces could be the base. So it could be our top and our bottom, the front and the back, or it could be the left and the right. So for simplicity's sake, I'm going to choose the bottom and the top. So those are my bases, because I chose them. Once I've chosen those as my bases, I forced the 10 to be the height, because it's the measure from base to base. And now I can figure out everything I need to figure out. So to do lateral, it's perimeter of the base. So we're looking at one of these. So if that's 15, that's 15. If that's 8, that's 8. So to get our perimeter, we'd find the sum. 15 and 15 gives me 30. 8 and 8 would give me 16. 16 and 30 would give me 46. And you can write all that out, but I really think you should find the perimeter, stick whatever it is right there. And then times our height, which in this case was 10. Evaluate that, and it will be 460 inches squared. That's that. When you go to find the surface area, you don't need to do it all over again, because we've already found out what pH was. So I'm just going to take that number and copy it over here. And then plus, it'll always be 2, times, to get our area of our base, it's 8 by 15. So we would just do 8 times 15. And at that point, we're ready to type it in. So you can grab your calculator and type in what I'm typing in. It's going to be 460 plus 2 times 8 times 15. And if we do that correct, I'm getting exactly 700 inches squared. One thing that should always check out, no matter what object you're dealing with, the surface area has to be larger than the lateral area, because it includes more of the object. So if you ever notice that your surface area is smaller than your lateral area, that's one of those red flags that something is not as it should be, so recheck your work. Next one, same directions. Example 2, find the lateral and surface area and draw this object. And again, we have a prism, but it's a different type of prism. In this one, the bases would be the 2 triangles, because they are the only 2 faces that are parallel to one another. So there's no choice this time. Those 2 triangles are our 2 bases. So again, our formulas, lateral area was perimeter times height. Surface area is that perimeter times height plus 2 times the area of the base. So what stands out to me, to find my perimeter, I've got the 3 and the 4, I'm missing that side. So I can't find the perimeter until I find this other side first. And what we should recognize, it's a right triangle. We know 2 sides, so we could use Pythagorean theorem and do 3 squared plus 4 squared equals c squared, because we're missing the hypotenuse. So that becomes 9 plus 16 becomes 25. And we root both sides, and now we know our missing side was 5. Some of you probably realize that we didn't need to do that work, because a lot of you remember your Pythagorean triples, that's a 3, 4, 5. So if you recognize the triple, I'm okay with you just knowing that it's supposed to be 5. But if not, that's how you'd work it out. So from there, lateral will equal, to get the perimeter, I'm going to add up the sides of the base. 3 and 4 would give me 7, plus 5 more would give me 12. Times our height, which I didn't label yet, but if those are my bases, the height on this one would be base to base, which is 10. and then evaluate, and we would get exactly 120 meters squared. And then like the last problem, when we go to do the surface area, don't do all the work again. We're going to write down, we already know pH is 120 plus 2 times the area of the base. Well, this time our base is a triangle, so a reminder from last chapter, to find the area of a triangle, it was a half the base of the triangle times the height of the triangle. So for this particular triangle, the 4 could be our base, and the 3 could be its height. So that would do a half times 4 times 3. And we could type it all in, some things that I do if I can. I'm going to notice in this case that, well, 2 times a half, that's going to cancel out. 4 times 3, I could replace with 12. And then I don't think we need a calculator to say 120 plus 12 would give us that our surface area is 132 meters squared. And again, our surface area is larger than our lateral area, not by a lot, which seems reasonable to me because that's not a very big triangle. This object is definitely longer than it is either tall or wide, so that seems fine. Notice how I'm labeling L equals a number in a unit, SA equals a number in a unit. That's what I expect to see on your papers as well. Example 3. Again, same directions. Find the lateral and surface area. Take a moment to draw this one, which we would call a pentagonal prism. And I'm calling it as such because if we look at our base, we've got a pentagon that is parallel to this other pentagon. So those are our two bases, and connecting them would be that, so the 18 is our height. One thing worth noting is that as it was already marked, these 5 sides of our pentagon are all congruent. So it is a regular pentagon. So when I go to find the area of that, from last unit, that's a half times the apothem times the perimeter. So I might want to deal with that first. And how I would deal with that first, in this case, I think it's worth our time to redraw that because there is a lot going on in that picture. So I'm going to, down here, redraw that pentagon, just to give myself some more space to work with. And things we knew from end to end was 6, and that's it. So what we did last unit was we drew in the apothem, which goes from the center, and then it goes straight down until it hits the side at a right angle. Then we drew this other one in, and our first step was to figure out that angle. So we did 360 divided by, in this case, there are 1, 2, 3, 4, 5 sides, which gives us 72. And then we want half of that central angle, so then we divide by 2. And now I know that that missing angle that's in there is 36 degrees. And then I'm going to use a little bit of trig to find the apothem, and then I'll know what the area is. So if this whole side is 6, the part I want is 3. It's 36 degrees, so I'm going to have to use sine, cosine, or tangent. This is what I'm after. So the 3 would function as the opposite. The A would be the adjacent. Opposite and adjacent would tell me tangent. So a little side work, I'm going to say the tangent of 36 equals 3 over A. Multiply by A, cancel, divide by that, so our apothem is 3 over tangent 36. And we are ready to go ahead and find everything we need now. So our lateral area, perimeter times height, so something we did last unit. To get the perimeter, since it's regular, I could just do 6 times 5. And I'm doing that because each side is 6, they're all the same, and there are 5 of them, times the height we already labeled was 18. So we're doing 6 times 5 times 18, which gives me exactly 540 inches squared. And then surface area is pH plus 2b We already know pH, so I'm going to write that down. That's the 540 plus 2, parentheses. And now I'm going to use this formula up here. So the half times the apothem, which is what we found there. So 3 over tangent 36 times the perimeter, which we already said here was 6 times 5, but we should just be able to put 30 there. So the half apothem perimeter. Now again, I would try to do some of this mentally before you grab the calculator. Like 2 times a half becomes 1, so I don't need those. And then 3 times 30 I could replace with 90. And then I think I'd be okay. So I'm going to type in 540 plus 90 divided by the tangent of 36. And then the assignment will ask you to go nearest tenth if you need to round. So surface area is approximately, because we are rounding, 663.9 is what I'm getting. And that would be inches squared. Like I've stressed before, please do not round multiple times throughout the problem. Wait until the end to type it in one time, so you're only rounding once at the end. So again, walking through this one, pentagons were our bases. To get the perimeter, we took 6 times 5, because there are 5 sides at a measure of 6 each. The 18 is connecting the bases, so it's the height, hence the 540. Down here, we redrew the base, so that way we had a little bit more room to work. We did what we did last chapter. We found the angle by dividing the 360 by the number of sides, and then dividing that result into 2. And then we noticed opposite and adjacent, so that would tell us it's a tangent problem. So we set up tangent to get the apothem. Then we plug that into the half AP formula, a half times the apothem times the perimeter, canceled out and did a little mental arithmetic, and then keyed it all in to get our final solution. Example 4. Cylinders, I don't think we need to do as many examples of, so I just have one of these. Find the lateral and surface area. Because of their lack of diversity, cylinders are going to be a lot easier for you. Unlike prisms, where the bases could vary, so your formula varies, cylinders are cylinders. So go ahead and draw this. Note that the 8 is pointing to that entire segment from end to end, and that will affect our calculation some. What that means is the 8 is the diameter. If we look at our formula, lateral area is 2 pi r h. And then surface area is same thing, but adding some more to it. So that would be 2 pi RH plus 2 pi r squared. If you think about pi r squared, remember that's area of a circle. So the only difference between lateral and surface area adds those 2 circular bases onto your object. So we would say our lateral is 2 times pi times, if the diameter is 8, radius would be 4, times base to base is 20, so that's our height. And we're going to type that in, and I would like it to the nearest tenth again, so 2 times pi times 4 times 20, which nearest tenth I'm getting lateral area is approximately 502.7. That would be centimeters squared. And then surface area, since I had to round that other part, I actually don't want to type all that in. I might go ahead and do 2 times 4 and get 8. 8 times 20 is 160 pi. But if I round this and I type it in, I'm going to double round, and I want to avoid that. So this became that part there. And then times pi times our radius, we already said was 4 squared. So key it all in, 160 pi plus 2 times pi times 4 squared. And this time around, I'm getting, it is approximately 603.2 centimeters squared. And just like prisms, Cylinders, the surface area must be larger than the lateral area because it includes more of the object. So always make sure that they're larger. Sometimes it won't be a big difference, but it needs to be bigger by at least some factor. And that is lesson 12-2. So you're going to have some time to practice these. There'll be some that are cylinders, some that are prisms. I tried to leave a decent amount of space between the problems. However, some of these, if it's like example 3, takes quite a bit of work. So if you feel like with your writing you can't fit it all on there, definitely encourage you to use another sheet of paper. Just make sure if you do your work on a different piece of paper that you have stapled it to there. Because as usual, to get credit for these, you are going to have some work. Some of them might not require a lot. Like if it's like number 1, I wouldn't be surprised if some of you just have answers. So something like that, not a big deal. If it's a problem like example 3, you need to have some of this work because that's not something that we can do mentally at all. So you will not be given credit for these kind of problems unless you have the work that backs up your answer. And this will be due next time.